Not so long ago, I remember that there were only two choices to be made, to SQL or NoSQL. But when I researched about the different data models available today, I realized that we have come a long way from choosing between a SQL and NoSQL database, don't you think? Welcome back, engineers. In this video, let's get to know some of the modern data models that are available for us today to make a choice from. So we'll start with the basic one. We have the relational data model. This has been there since ages and this works very well for most of the use cases. So in a relational data model, we map data in the form of tables, and each table will have some rows and columns, right? And the popular examples are MySQL, PostgreSQL, and SQL Server. So this type of database is mainly used when you have structured data and when you need strong atomicity guarantees and when you have transactional systems, right? So this is an age-old data model that has been there since ages, and it works and powers many modern day applications as well, right? So fantastic choice for data when there is relations between them. Let's look at the next one. So the next one is the document data model. So this stores data in terms of documents, especially in terms of JSON or binary JSON, which is BSON, right? So examples are MongoDB and CouchDB. We have seen some demos of these two databases in my previous videos as well. So this type of data model is used when you have semi-structured data and when you need flexible schemas, right? So when you don't know your schema or when you need flexibility during runtime, this database or data model is a very good choice. So it's mainly used when nested or hierarchical data is involved. So let's say that we have some comments coming for any blog post or any Facebook post. So we know that a comment cannot exist without the post. So there is some hierarchical relationship there. So in such situations, we can make use of document data model. Again, this type of databases are excellent for scalability and availability because they come with built-in replication systems and so on, right? So that is all about the document data model. Let's move on. So the third one is key value data model. So in this data model, we store data in terms of key value pairs, right? So there is a key and against it there is some value. So there can be of different data formats. Key can be a string and value can be a string, number, or sometimes even objects are supported these days, right? So the idea is to store them in key value pairs and mainly to store them in memory so that we get faster lookups and very performant systems. So examples of this data model is Redis, DynamoDB, and React, and these are mainly used during caching applications and also for some session storage where we need to store some temporary data and when we need quick lookups, right? So a fantastic data model for creating high performance systems. So let's see what's next. The next one is a columnar data model. This is a very interesting data model. So instead of storing rows and columns in tables, we store data in columns instead of rows. So which means that in a SQL database, we have a row with common columns for every row. So if there is no data in some columns, those columns will still need to allocate space and keep them as null, for instance. But in columnar databases, every row has its own set of columns, and some rows can have fewer columns, some rows can have more columns, right? So this has its own applications. So some of the examples of columnar data model databases are Amazon Redshift, Google BigQuery, and ScyllaDB. And this is mainly used when we have large data sets involved and we need to run some heavy analytics workloads on this type of data. So this is where this columnar data model is heavily used. Let's see the next one. So the graph data model is used when you want to store data as nodes and edges. So the relationship between one node to other node can be represented through some edges, right? So these are mainly seen whenever there is a network involved. So it can be some computer network or a social network where one person is in a relationship with some other person either through friendship or through follower mechanism. So in these type of situations, we can make use of graph data model. This is also seen in recommendation engines, and some of the examples are Neo4j, Amazon Neptune, and GraphDB. So definitely check this out if you are in need of any network storage. So the next one is object-oriented data model. This is mainly used with Java applications, and it is very tightly coupled with the concept of object-oriented programming. So in this data model, the data is stored as objects and it follows the principles of object-oriented programming. So some of the examples are object DB and DB4O. And the main use cases are when you have complex data structures with object hierarchies, we can make use of object-oriented data model, right? So with this data model, we can leverage the concepts of inheritance and abstraction and polymorphism and things like that. And if you have some complex data structures like that, definitely make use of object-oriented data model. And the next one is time series data model. So this is very useful when you have chronological data, when your data is dependent on time. And some of the examples are IoT sensors, which are continuously sending out metrics about some machine they are constantly monitoring. They're sending out data about that machine during some fixed interval. Or you are some monitoring applications where you are monitoring the state of any machine or anything like that. We can make use of time series data model. So how is this different? The indexing is different and it is optimized for querying chronological data. So there are timestamps attached to every record, and with every timestamp there is some metadata. So if you want to take an average of, say, last 1 hour, what has been the heart rate of some machine, so you can make use of time series data for that, right? So some of the examples are InfluxDB and TimescaleDB. I think MongoDB also has a support for time series databases. So definitely check it out if you are in need for any time dependent data models. And the next one in the list is multimodal data model. So this is self-explanatory. The engine itself has support for the different types of data models that we have seen so far. So when you have a need for, let's say, a document database plus a graph database in one engine, you want to club them together, you can make use of multimodal data models. So some of the examples are ArangoDB and CosmosDB. So this gives greater flexibility in choosing a data model. So the next one is vector store data model. So this stores data as high dimensional vectors. This is mainly used for similarity search, and this is a common database that is being used in machine learning, especially with LLMs as well. This is a main database that is being used. So some of the examples are Pinecone, VV8 and FICE. So the data is represented in numbers mainly, and it is represented in higher dimensions, and because of this vector representation we can do vector manipulations or vector calculations, multiplications and so on, so that we can do some kind of semantic search between two users or two products or anything like that. So whenever we have a need for some similarity searches, we can make use of vector databases. They are very fast and very efficient. So we can also achieve some kind of clustering using these high dimensional vectors. We can make use of unsupervised learning to achieve some kind of clustering. So if you are in the space of artificial intelligence and machine learning, you already know about these kind of databases. And the next one is a blockchain data model. So in this data model, we store data as immutable, cryptographically secured chain of blocks, right? And some of the examples are Ethereum and Hyperledger. And the main use cases are obviously cryptocurrency and any kind of decentralized application like cryptocurrency, we can make use of blockchain data model. So the idea of blockchain itself is a complex one, and if you are in need of any decentralized transaction systems, I think blockchain data model would be a good choice for that. Next in the list is spatial data model. So this is a database that is specialized for spatial data such as geographic locations or geometric shapes. So we have support from Postgres with PostGIS extension. MongoDB also has support with geospatial indexing. So when you have location-based services, we can make use of spatial data model, right? And last but not the least, we have the event store data model. So in this data model, we store data as application state, and every application state is stored as sequence of events. So let's say a database node is down and we have this sequence of events in hand, and if we play the events in that particular sequence, we can bring it back to the original state. So that's where sequence of events help. So some of the examples are the event store DB and also Apache Kafka, which is not exactly a DB, but it deals in sequence of events and message queues and so on, right? So some of the use cases are wherever you have event-driven applications, definitely check out event stores like this, right? So these are some of the data models that we have available today. So now that you're familiar with these models, you can make use of them, go deeper into any of those models, and at least you will be able to talk about these different options when doing system design, right? So that's the whole idea. And having said all this, I am sure I've missed one or two of the data models available out there. So if you have come across, or if you are using any other data model that I have not listed here, so definitely put it in the comment below so that I can learn, you can learn, everybody can learn. So let's keep the learning and sharing going on. So that's all for this video, guys. Thank you so much for watching. Do subscribe if you haven't done already. Do leave a like if you found this helpful. I will quickly see you in the next one. Cheers.